So let's talk about the product that's formed when we have a Lewis base interact with a Lewis acid. So it's called an acid base adduct, an acid base adduct, right? This is the compound that forms that contains this coordinate covalent bond between the Lewis and acid base. So here's an example where we have a fluoride ion interacting with Bf3, which behaves as a Lewis acid because this boron can accept an electron pair from this fluoride ion, forming a coordinate covalent bond to form this acid base adduct. Here's another example where we have ammonia interacting with silver, and we have two ammonia molecules that react with one molecule of silver to form this acid base adduct where we have two ammonia molecules that's bound to this silver. So acid base adducts can also react with another Lewis acid or a Lewis base to form a new adduct. So here are two examples of that. So we saw how we formed this acid base adduct here with silver bound to two ammonia molecules. This could react with a base like cyanide, right? And essentially what happens is this cyanide displaces the two ammonia molecules to form this new adduct. And then we're left with a new base, which are the two ammonia molecules that have been displaced. Another example is CO3 reacting with SO3, where one of the lone pairs on this oxygen molecule can react with this sulfur molecule to form this new adduct, SO4 or sulfate, and then we're left with a new acid, CO2. So when an acid base adduct reacts with a base, it forms a new adduct and another base, right? Because it's just displacing the Lewis bases that were in the acid base adducts. When an acid base adduct behaves as a base, we end up forming a new adduct and a new acid, a new acid. So you have seen acid base adducts before. You have seen them before. And we commonly refer to them as complex ions. We refer to them as complex ions when our Lewis acid, or we have this central atom that is our Lewis acid, is usually a transition metal. And then it's surrounded by some ions that we call ligands, So in this example, silver is our central atom and it's also our Lewis acid. And the two ammonia molecules are our Lewis bases, and we call them ligands. So we'll talk more about this terminology in the next section, which will be called coordination chemistry, right? Because complex ions are also referred to as coordination complexes, where we have some transition metal that's coordinating some ligand molecules, and they're connected through coordinate covalent bonds. So the charge of the overall complex, right, is the sum. It's going to be the sum of the charge on our central atom as well as the charge on our ligands. And something that's interesting about complex ions that I want to highlight is the formula cannot be predicted, right? So even though I've drawn this formula, this has been determined experimentally, right? Experimentation was done where they saw that if we mix ammonia with silver, silver is going to coordinate two ligand molecules of ammonia. This was determined through experiment. through experimentation. And there's a whole field of coordination chemistry that does this very thing, right? That actually designs these coordination complexes, determine what their structure is, and then it structure has these cool, unique functions. All right, so I will pause here. We'll talk more about coordination complexes next week.